Hey guys, it's Kong, and in this video we're going to be doing 6 substitution problems of system of equations. And this is the first basic method that I think students in Algebra 1 should pretty learn quickly. The second method is elimination, which I'll make a separate video on. So for this first problem, we have y equals negative 3x and y equals 6x minus 3. Just to note that there should be a curly bracket here. You don't have to put it all the time, but the reason why in some textbook you see a curly bracket for those two equations because they work as a system. Because you find one of their values, you can solve for the other, and then when you plug both of those values in, they make both sides of the equation true. That's why they work as a system. So this is why the name of system of equations comes into this. So the first thing I see for this case is that negative 3x right here, I can plug in for the second equation right here. So since they were written y equals negative 3x, I don't have to solve or isolate what y is. I'm just going to directly plug this into right here for my second equation. Just to know that this is my first equation and this is my second equation. Doing that, we get negative 3x. And let me just rewrite the earlier side right here. And now what I want to do is to isolate x, so subtract negative 6x to both sides. That cancels out, that gives me negative 9x. And now we got negative 9x equals negative 9. And now what should we do? If you say divide, that is correct. Because of order of operations, in order to isolate x, since multiplication and division they are opposite of each other, you can undo that by dividing. Doing that, negative 9 over negative 9 is just 1. So we're just left with x equals 1, positive 1. And then some students think that we are done, but we are not because we only found what x is. We need to find what y is. So now what do we do? If you look carefully, we know what x is, so we can just plug into either equation 1 or equation 2 right here. I like to do equation 1 because it's much simpler. You look at equation 2, it is 6x minus 9, but I'll show you either one works. So let's just do the first one. Y equals negative 3. Let's say we plug in that. We should get y equals negative 3 because negative 3 times 1 is negative 3. So we know what our y value is. That's equation 1. Let's say you just plug into equation 2. So y equals 6 times 1. That gives, of course, minus 9. So 6 times 1 is just 6 minus 9. That gives me negative 3. Either one works right here. It doesn't matter which one you plug it in. And now on how do we check our work? I'm not going to do this for every problem, but for this case, for problem 1, I'm just going to show you how you can check your work. Alright, so I'm just going to plug it into the first one. So we have negative 3 equals negative 3 times 1. And now negative 3 stays the same on the left. Negative 3 times 1 is negative 3. That is true. Now let's check in the second equation. Negative 3. Okay, 6 times 1 minus 3. So negative 3 stays the same. 6 minus 3. In this case, oh, sorry. I made a mistake here. This should be 9 right here. Right there. That is negative 9. That is true. So that is the problem for number 1, which you get x equals 1 and y equals negative 3. For problem 2, we have y equals negative 2x minus 9 and y equals 2x minus 1. You see, it's just y that's isolated. That means that you can plug in either one for y. Let's just say that I plug in equation 2 into equation 1 because the problem before we did, we plug equation 1 into equation 2. So if we do that, we should get 2x minus 1, and we write 2x minus 9. And now I have to isolate my x. So I could either minus negative 2x from the left to the right, but in this case, for negative 2x on the right, I will add it to get rid of that negative to both sides. Doing that gives me 4x minus 1 equals negative 9. I'll now add 1 to both sides. We get negative 8. And then divide both sides by 4. We get x equals negative 2. That is our value. And now I'm just going to plug this into equation 2. I can still plug into here because problem 1, I plug into equation 1. It doesn't really matter which one you do. So just rewrite that. Y equals 2x minus 1. Y equals 2 times negative 2 minus 1. Now that is 4, negative 4 minus 1, and y equals negative 5 in this case. And I'll just to quickly check my work, right, check negative 5 equals negative 2 times negative 2 minus 9. That gives me positive 4, and then that should give me negative 5. And that is true. And now the second equation, negative 5 equals 2 times negative 2 minus 1. Negative 5 equals negative 4 minus 1. That gives me negative 5. Equals negative 5. Therefore, my solutions to this problem is x equals negative 2 and y equals negative 5. Problem 3 is a little bit harder because we have negative x minus 3y equals negative 24 in the second equation. But it doesn't really matter because they really isolated my y, so I know what my y is. So I can plug it into right here, or I can isolate and solve for y, and I can plug into the second equation. But that is just too much work. So I'm just going to plug this into the second equation and then isolate y. So doing that gives me negative 3x minus 3 times this whole thing right here. 6x minus 6 equals negative 24. And now we have to distribute this negative 3 into 6x minus 6. So negative 3 times 6x is negative 18x. And now negative 3 times negative 6 is positive 18 equals negative 24. And now I have like terms right here. So that means that I have to subtract them. Negative 3 minus 18 is just the same thing as adding 3 to negative or going away from it. So that gives me negative 21x plus 18 equals negative 24. Isolate 18. We get at negative 21x equals, this is going to be negative 24, be careful of the sign, minus 18. Therefore, we get negative 42. And dividing both sides by negative 21, we get x equals 2. And now I can plug in this into the first equation right here. There, and draw arrow. This gives me y equals 6 times negative 2 minus 6. Y equals 12 minus 6. Therefore, y equals 6 in this case. For problem 4, it's a little bit more trickier because since they did not give us x or y by itself, we can't directly substitute anything into x or y. So in this case, we must either choose one of these equations and isolate x or y. First thing I see is that the first equation right here is much easier to deal with. So I'm just going to go isolate x because y already has a coefficient in front of it. So that's going to make it more work because you would have to isolate x and then divide by negative 5. That is not good. You would have a fraction. All right. So first thing first is to rewrite this equation down. Now I'm just going to add 5y to both sides. So 5y plus 7. And there it is. Here is my x here to substitute right here. That is not my answer because it doesn't have a value. It is something that I can directly plug into something else. So I'm just going to plug this into second equation right here. Doing that gives me 2 times this big substitution 5y plus 7 plus 7y equals negative 20. And now distribute 2. Now we get 10y plus 14 plus 7y equals negative 20. I have my common like terms right here. Doing that gives me 17y plus 14 equals negative 20. Subtract 14 both sides gives me negative 34. And divide both sides by 17, it should give me a negative number, which is 2. And now I found the value of y, which is negative 2. And now I can directly plug this into the first equation right here, or second equation. It doesn't really matter. So plugging that in gives me negative 2 equals 7. X minus a negative 10 here equals 7. Be careful of this sign right here. So distribute that negative into that parenthesis gives me a positive 10. Now subtract 10 to both sides. X equals negative 3. And now I found the value of negative 3. For problem 5, we have 3x plus y equals 9, 2x plus 8y equals negative 16. First thing I would do is that I notice this y here in the first equation is just by itself. So that makes it much easier because I can just isolate x to the right side. Doing that gives me y equals negative 3x plus 9. Now I can substitute this into the second equation. Doing that gives me 2x plus 8 times negative 3x plus 9 equals negative 16. And now I can just distribute this 8 into this parenthesis. So 8 times negative 3 is negative 24x. And now 8 times 9 is 72 equals negative 16. And now I have my like terms right here. That is negative 22x plus 72 equals negative 16. And now minus negative 72 to both sides. This gives me negative 88. Now divide both sides by negative 22. We get 4 in this case. And now I can plug this in to my first equation or second. It doesn't really matter. Now 3 times 4 plus y equals 9. That's 12. And then subtracting 12 to both sides gives me a negative number because 12 is bigger. That's how I think of it. Negative 3 in this case. And these are our two solutions to this system. For question 6 is much different because now I have none of my variables are by itself. They both have coefficients in front of them. And now in this case, I recommend choosing which equation you think would be much easier to isolate and then make it by itself and then plug that into a different equation. So in this case, I would notice that second equation here is much easier to deal with. And now let me just isolate for x right here. Doing that, first thing I would do is to add 3y to both sides. Therefore, giving that, and then divide both sides by 8. Remember, be careful that when you're dividing the whole thing, you have to divide each and one of these by the same thing. So 3 over 8. Y you can't simplify that into you can't simplify that anymore. And 16 over 8, I will simplify that on the next one. This is just 2. So x equals 3 over 8y plus 2. And that's what we have for x. So plug that into the first one right here or the second. Doing that would be negative 6 times 3 over 8y plus 2 plus 6y equals negative 12. And now be careful of this fraction. Don't get overwhelmed. Negative 6 times 3 over 8. Think of this. 3 over 8. Yeah, this is just negative 6 over 1. So you do across horizontal multiply. 6 times negative 3, negative 18 over 8. Now, can you simplify that? Well, you know that 2 goes into 8, and it has to be 9. So 2, they both could work with 2 in this case. You can't do 4. Can't do 3 because 3 doesn't go into 8. So in this case, you would have to divide both sides by 2. That gives you negative 9 over 4. And that's the simplest form that you can do in this fraction. And now negative 6 plus 2 is negative 12 plus 6y equals negative 12. And now for this, we have our like terms right here. Again, don't get overwhelmed. Adding fractions is pretty simple. Now let me just put it down here. I'll erase it later. 9 over 4. Add 6. This is just 6 over 1. Think of that. But then you can't add fractions like you can for multiplying fractions. You have to have a least common denominator for both. Since the least common denominator is 4 in this case, 1 times 4 is 4. That means that I must multiply 6 over 1 by 4. Therefore, giving me 24 over 4. Now, negative 9 over 4 plus 24 over 4. That would be 15 over 4. And now, we're 12 minus 12. And now add 12, that's going to give us 0. In this case, negative 12 plus 12 is just 0. And now, in order to get rid of this fraction, you have to multiply by the reciprocal. Both sides of the equation by 4 over 15, the reciprocal. Doing that. Now, you may be wondering, why does this get rid of it like that? Well, you were to think of it, let's set it up like this. 4 times 15 is 60. The same with 15 times 4 is 60. That gives me 1. That's how they cancel out. And now we are left with y equals 0. Because 0 times 4 with 15 is just 0. And now plugging things into the second equation or the first one, doesn't really matter, gives us negative 6x plus 6.